Good morning, mathematicians. You ever just sit around and you just think to yourself, Shakira, Shakira, da 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 da. So I'm thinking that constantly. Oh, I didn't want to go there. We got some viewer questions lined up
You
for
just think to
today.
yourself, Shakira, Shakira.
Ugh. Gotta organize myself. Ah. Ay. Better close that. Yeah. We've got some questions. So, opening it up with, I had someone email me some questions to start live stream off with. So that's what we're going to start with. My little live stream notepad here. I do have this group theory question from yesterday. Actually, maybe we'll start with the group theory question. Charles asked this in yesterday's stream. So we've got two groups, G and H, and they're cyclic, and we want to know when there is, I suppose, an isomorphism. Actually, maybe I should wait to see if Charles shows up, because I don't want to misrepresent their question. But I believe they're asking about when there's an isomorphism sending xi to yi. So, first off, notice that the orders must be preserved, right? That's a condition for group homomorphism. So whatever the order of this element is, it had better be the same as the order of this element. It must be the same. The other thing is that we want we want to make sure that this element here, if it's an isomorphism, it had in the target group, it had better generate the whole group. So this element needs to generate the whole group, and that also means that this element needs to generate the whole group. So when does that happen for a cyclic group? Well, certainly it's not going to happen if, let's say, n is the order. Then certainly I will not divide n. Or rather, sorry, if I does divide n, like this, say, and ik both not equal to 1, then y has order k, right? Y to the I has order k. So it can't possibly generate the whole group. In other words, you need I and n to be relatively prime. And that's it. That's all you need. So those are the sort of necessary conditions. Are they sufficient? Well, that I would maybe just check. So definitely, if this is an isomorphism, I and n have to be relatively prime. But is it all? We also still need to check that for every such I, that this is an isomorphism, and indeed it is. Good morning, Ken. Good morning. Okay, so I've got some questions from the office hours for office hours here that I received in an email ahead of time, although I did not think about these questions ahead of time. I feel really tired today. I did a harder run than usual, but it wasn't crazy yesterday. Tired. What would I need to see from someone for them to prove to me that they know basic category theory. 2 conditions. The method must not be some sort of time test. The person does not know more than high school level pre-rigorous math. Whoa. Then I think it would be very hard. I think it would be very hard. Yeah. Because, I mean, so the thing is, like, in today's world, like, it's very easy. Well, I mean, even 100 years ago, you can just copy stuff out of a book, right? In fact, I've interacted with people who seem like they may or may not. Yeah, yesterday chat was really active. That's right, Nerd Coke. I know people were sipping on their coffees or something. But yeah, because the problem is, so you can like copy paste anything, and I don't know. I've certainly interacted with people who seem to just more than once. There's been numerous occasions where I've interacted with younger people online, and then they're very clearly just like copying words, and because they want to seem smart or something, and it's like, okay. And then here's the thing. Yeah, I mean, unfortunately, okay, there's issues with timed tests and stuff, and yes, it's not very a realistic way that you'll be like performing mathematics in the real world, but I mean, it's still a pretty good way to see how well someone knows the subject. Like if you can drum up things, basic definitions and proofs pretty quick in a controlled environment, it's a pretty good way to see. And then it's also going to be definitely difficult pre-rigorous math. I mean, yeah. The thing is, I think in order to truly know basic category theory, you have to go beyond the pre-rigorous math. I mean, certainly you can have an understanding of the concepts and like what they mean and how they fit together, and maybe even use them in an appropriate context. But there's really just no replacement for proof and offering a proof. So, can we talk about triangulated categories? Absolutely, we can. It's funny you asked that. Someone last night in a Discord server was asking for recommendations on a good beginner text on cohomology theories, on derived categories and triangulated categories and things like that. So absolutely we can. Yeah, so I would say that is, then it's a difficult goal to accomplish. Maybe some worked exercises, worked solutions that are very clearly in their own words. That would be the best thing to do, but I mean, that means worked proofs. So that does conflict with B a little bit. What topics would I say forms part of what basic category theory, and why? I mean, I would probably say, so there's this, I think I've mentioned before, there's a reading group I've got going on. Or, well, it's not mine, I should say. I'm sitting in on it. Some undergrads are learning category theory. And we're going through Tom Leinster's notes, and I would say Tom Leinster's notes, which are called basic category theory. Yeah, that constitutes, I would say those notes constitute basic category theory. I mean, maybe they, whoa, look, there's me drinking coffee in the past. Amazing. Well, hey, I'll bring up the PDF, actually. Hello. Hello, Messi. You think storytelling is undervalued in math, but proofs are good too. Yeah, that's true. I mean, storytelling is very good. And I like to think that I'm I'm at least an okay storyteller. I like to think that I give talks that are entertaining. Yeah, Leinster's notes are really good. Yeah. Yeah, but the question was going back to how do you demonstrate to someone that you know something like basic category theory, and I think that's hard to do just through storytelling, because like a historian could probably do some really good storytelling about basic category theory, but that may not indicate that they know it. Good morning, Charlie 3K. So yeah, I mean, I think everything in here, I would say this is, yeah, I mean, this book, I would say if you know this book, I would say the entirety of this book constitutes basic category theory. Like I can imagine a course on category theory, a 1 semester course that goes through this book. That's what I would say is basic category theory. You've had a delightful morning today. Awesome. Love to hear it. Of trying to decipher algebraic topology papers from the 50s. Nice. That's, let me know if you find some good ones. Well, you're saying trying to decipher, so probably that means they're not the easiest to read. But tell us your findings. Fully mastered direct construction. Just need to tackle the others. That's good. That's good. Good to hear you're making progress. Wait, let me, before it gets buried in chat, let me just write down the word triangulated categories. Do I know how to show that the free vector space of a topological space, mod, its connected parts, is isomorphic? The free vector. Okay, so X is a topological space. And then I take the free vector space, say over some field F of X. And then I mod the connected parts? Do you mean the connected components of X? The connected component of X? In what sense is this a mod? What kind of mod is this? You like as a vector space? I take the free vector space and the connected components. Is isomorphic to the quotient of the free vector space of the topological space over the span of differences of characteristic functions of the start and end point of a path. Oh, I think, okay. Okay, I think I know what you're trying to. I think I know what you're talking about. You're talking about how we create the universal cover of a topological space, right? Where we form the path space of X, and then we basically like quotient out by the loops, Yeah, we or not. No, we don't quite quotient out by the loops, but am I correct? You're trying to talk about the construction of the universal cover in terms of paths. Um, you managed to subscribe to archive and subscribe to 8 areas. Yeah, I would not. I mean, when I first did it, I subscribed to 1 area, and I was like, "This is too many emails." Wow, 50 papers. Yeah, that's yeah. You have a friend who's an applied mathematician and looks down on higher math, such as category theory, for being too far abstracted from real world applications. Wish you knew how to respond. Well, don't worry. There's plenty of people in category looking down on him for not being able to understand category theory. As not 100% a joke. I mean, okay, I'm not actually throwing shade on applied mathematicians. Um, I don't know. I think it's kind of stupid to look down on anyone from. I think both perspectives are kind of. I think both perspectives are kind of stupid. Um, yeah, I mean, yeah, I don't know. I think it's just shows probably some sort of. If I had to guess, it's almost like a intellectual defense mechanism. On both sides, like either category theorists that are looking down on applied mathematicians or vice versa. Because probably there's a part of them that the math scares them or they know they can't do it, and it's just easier. Instead of admitting that, it's just easier to look down on this other area of math. I mean, I don't know, it's just so incredibly stupid. There's so many areas of math that contribute to the world in so many different ways. And also, guess what, it's like music. I mean, in my mind, it's like music. Like, what do you mean too abstracted? Too abstracted for what? To be useful? Well, guess what, category theory has proven useful. Not as much in pure math yet. Maybe that won't ever come to be the case, but yeah, I don't know. You should send your friend this video, and guess what? There's plenty of people that do abstract category theory and do applied mathematics. I mean, just yesterday there was someone on here who was like, "Oh yeah, I'm a mathematician working in data science, but I'm studying category theory for fun." So I think it's so stupid. I think it's like when I was a teenager, and I was like very only interested in one genre of music. Everyone else is stupid. There's no other genres of music that are worth listening to. Blah blah blah. And it's so stupid, because it's this false, pretentious standpoint, and ultimately what you're doing, you're shooting yourself in the foot, right? You're robbing yourself of joy. It's like, I don't know. Personally, I think it's better to try and be open to as many genres of music, to as many genres of film, to as many genres of mathematics, to as many kind of food as possible, because you're alive for an extremely short amount of time. I'm going to try to live forever, but we'll see. And, joy can be hard to come by, especially for some people in this world. I mean, some people have very nice, comfortable lives. Other people don't. But you never know what's going to happen, so you may as well take advantage of the joy that is before you and experience all of the things that life has to offer. Why not life max and experience the breadth of things out there? Now, it's okay if you dip your toes into something and you don't like it. That is totally fine. It's also good to know what you don't like. I still think it's good to try to make yourself like other things. But if you really know you fundamentally don't like this thing, great. Stay away from it. But don't look down on other people, especially trust me, there's a lot of people looking down in the opposite direction. So your friend's insane. I don't know how to respond to him either. My response is probably not the best response, but yeah, I'm sorry. That's just insane. That's just insane. Any chance I can talk about L packets and Arthur packets? I could. Let me put this on the... triangulated categories are first, then Arthur packets and L packets. Those are next on the list. Yeah, sorry, Alakeen, I'm just not sure exactly I understand your question. I don't know if you like have a... I know you can't put links in chat, but like if it's a question from a textbook or something, I don't know. Well, it needs to be abstract to be simplified. Otherwise, you end up making pi equals 3. Yeah. Hey, Charles. Good to see you here. You watched the answer. Awesome. But your question yesterday, was about homomorphisms, not isomorphisms. Oh, okay. Well, so I believe homomorphisms should still preserve order. But I guess the question is, if you just... Wait, so you want to find a homomorphism? Yeah, maybe I should ask a clarifying question. Is it that you want to find a homomorphism from G to H such that phi of xi is yi? And figure out for which y, for which I this is possible? Well, that should always be possible, right? Because, I mean, you just take... If x and y are the generators, you just take the homomorphism that sends x to y, and then you're done. So maybe that's not your question. You can always define a homomorphism by saying, I'm going to send xi to yi. But I guess that ends up just being this homomorphism that sends x to y. So I don't know. Yeah, maybe if you can add some clarifying things. There should be more collaboration between seemingly unrelated departments, and it's sad how it's separated. Yeah. One of the streamers you shared, his vision is to combine sociology with category theory. I mean, there's definitely like network analysis stuff that could be... I do think, yeah, so this is one thing, I think it would be cool, again. Could be good, could be great that there's that category theory could help you formalize ideas there. But also, I don't know, sometimes I think, yeah, I mean... But, like, I don't know. It's not necessarily a given that it is going to be useful, right? And, for example, like network analysis, like graph theory, directed graphs, which are close to categories, I feel like have already proven a lot of usefulness. I don't know what I'm saying. A rad coming through with the suggestion to go to Hatcher. Category theory can be very useful in computer science. Yeah, I mean, one day I would like to program in Haskell. Just because I know it's category theory heavy. Category theory for computing science and others. You have an interest in L packets. Well, we'll get to them. Triangulated categories are first. But I'm sorry, Femnol. I promise I'll get there. I'm just making my way through chat. Most profound result in category theory. Let me add that to the list. Studying differential geometry can't understand why tangent vectors are defined as derivations. Aha. In your mind, tangent vectors should be one thing, and derivations, and the derivation should be isomorphic. Well, it depends on a matter of perspective, right? There's like 20. I may be exaggerating, but there's like 20 equivalent definitions of tangent vectors, and derivations is just one of them. You might prefer the one that takes that says, oh, it's all paths through M whose evaluation at 0 is the point P, and then actually it's the span of the derivatives of those paths. That's maybe more in line with what you actually think of as a tangent vector, right? So you could instead take that as your definition and then go ahead and define it, and then go ahead and later prove it to be derivations, right? That doesn't have to be the definition. Lots of people take it to be because, for certain reasons. Yeah. Well, then conceptually start with the one that you prefer. Take that as your definition. Yeah. Oh yeah, Arad here saying the same thing. Question is about the condition for the orders of x and y so that the map sending xi to yi is a homomorphism. Oh, so sorry. Let me see if I can phrase it this way. So let G and H. No, I'm still confused. Oh, okay. G and H be cyclic. Let G and H be cyclic. Define phi I. Wait, but didn't you say yesterday that x and y have to be? Maybe you didn't say they have to be generators. I thought you did say that. Yeah. So, sorry, I'm still confused. X and y are two fixed elements? Yeah, I'm confused about that. I'm sorry. The best definition for tangent vectors is the algebro-geometric one. I mean, okay, that is kind of nice. But again, I feel like this is another clear instance where actually the intuitive, sensible definition is probably this one in terms of paths. And then you realize you can rewrite it in terms of derivations. And then later when you're struggling to like, oh, how do I define tangent space in algebraic geometry world? Then you're like, oh, well, which of the 5 definitions of tangent space I have in differential geometry world can be made algebraic? Oh, well, it's the one about derivations. So that's the way I feel like it goes. I'm pretty sure Lee explains some of it. Is a great problem solver a must for a researcher? I guess it depends what you mean by a problem solver. If you mean Math Olympiad, most people say no. I guess I would say no as well. Clearly, there's lots of award-winning mathematicians that aren't Math Olympiads, but like, go look at like the list of Fields medalists, and go look at or people who have won like crazy awards, and then go look at how many of them were gold medalists in the IMO. Not quite a coincidence, but I mean, by definition, you're as a researcher, you're solving problems all day long. So, ability to maintain curiosity and ask meaningful questions, just as important. Yes, True, just as important, but you also do need to be able to solve problems simultaneously. Your definition is already in terms of paths? What? Just remembers only the first Taylor coefficient of the path? What are you talking about? What are you talking about? G and H be cyclic groups generated by X and Y. Right. So, well, then there's no conditions on the orders of X and Y. Oh, sorry. Okay. Okay. Sorry. I misunderstood. Right. These groups aren't isomorphic. I see. And you're trying to see. I see. So you're defining phi I to be the map which sends xi to yi. Okay, I think I understand. And now you want to know when is this a homomorphism? Well, yeah. So one way to see this is, again, the fact that phi I has to, because it's a homomorphism, it has to preserve order. This is known result. So that means that wait, is this true? Yeah, it is true. Or is it? Does it just need to divide the order? Now I'm spacing out. No, group homomorphisms preserve order, right? I'm crazy. This is like basic math. Yeah. Oh, if F is injective. Right. I see. Yeah, it has to. I see. Yeah, it has to divide. Right. Okay, that makes more sense. Because, of course, we should have quotients of cyclic groups. Right. So, right. So the order of each element, so in particular the order of X, the order of phi. No, why am I calling this phi I? I should just be calling it phi, because it's just lifting each power to each respective power. So what does that mean? That means that the order of, say, the image of X, which is Y, has to divide the order of X, right? So this is exactly this is the one condition we need. So this is necessary, but it's also sufficient as well. As long as you have this, then you can prove it's a homomorphism. There's another way. So, I mean, this isn't. We just proved this in, like, we just talked about this in general for cyclic groups. If they're finite, remember that all cyclic groups are of this form. It's Z mod n m to Z mod n, right? And so, I mean, the only subgroups of this, right? Because to give a map from one group to another, I mean, basically this is like you basically just pick what you want your kernel to be. And so all of the subgroups of this are just going to be of the form Z P K, or Z, I don't know, ZK, where K divides M, right? And then, of course, you know, if K divides M, let's say it has to be like kn, and so what you're gonna get here is some map like this. Well, that would be in the surjective case. Of course, you could also, this could be quotienting onto some yet smaller subgroup, say ZL, and then that ZL is included in here, for example. Oh, Hobster, my baby boy. Yeah. So I don't know, Charles. Is that enough to put you on the right path? Let K divide. You know it, Hobster. You know it. Yeah, Charles, I don't know if that answers your question sufficiently, but I'm finally going to get around. Fimnel, I don't know if you're even still here, but I'm gonna finally talk about triangulated categories a little bit. So, what is a triangulated category? Why is a triangulated category? Don't know if choosing the kernel is enough. Well, between these two, I mean, no, you're right. Choosing the kernel is not 100%, but yeah. Well, but it kind of does, right? Because I guess you then want to choose which group you're including into. So your choice of kernel, right? You definitely surject onto. This is category theory indeed. Well, kind of. Right now I'm finishing up some basic group theory, but we're about to talk about triangulated categories. But definitely your choice of kernel totally determines like the quotient map to Z M over K. But then the only choice you have left is then, so maybe either that's your target cyclic group, or you embed this into some L where this number divides L. That's the other part of the choice. Add suspenseful music. Yeah, I should get like a little soundboard so I could make I could make things. Dank memes indeed. So okay, triangulated categories. What's the idea? Well, so the sort of classic example is the derived category of an abelian category. If it doesn't have to be bounded, I guess, but if abelian category scares you, just think about abelian groups or vector spaces. And so, what makes a derived category? What makes it a triangulated category? Well, okay, there's a big list of axioms. I'll put it up in a second, but one of the important things is that we have a shift functor. So what I mean by that is if we have a complex, right? So this is just like A1, A0, A1, ... right? We have a complex. We can then perform the shift, and this will be a new complex where, despite we put the 1 there, it actually moves things to the left. So, oh no, I moved it too far to the left. So wait, does it move it to? I always got confused. Yes, it moves to the left. And so you get this new complex. We're now in the so A1 in degree 0, for example, is A shifted by 1 is now the first degree of the previous complex. Um, so, what was I going to say? Yeah. So that's sort of one of the fundamental ideas here. And then the other thing is that, well, say we started with an abelian category, right? Then we go over to the category of chain complexes. And then finally we localize that category to get the derived category, right? We like localize at the quasi isomorphisms. And the problem is well, we like abelian categories, right? I mean, we do want to study cohomologies, but we also don't want to let go of having an abelian category. And in particular having the idea of an exact sequence. But now maybe we've lost having an exact sequence. But is there some sort of structure that's retained from that? Also, we do know sometimes that short exact sequences, right? So if I have a so in chain complexes, I still have short exact sequences, right? And we know that cohomology tends to give us a long exact sequence. I guess I should be putting dots here. And then there's this, the connecting homomorphism is some sort of degree jumping map, right? Some sort of like degree jumping map here. So these are kind of the fundamental ideas. And now there's one other important thing though, and that's having the cone. And I can't do it just from my head, so I'll have to you've only seen negative degrees for cotangent complexes in deformation theory. Is it true? I don't know. Do I actually have... I have a char open because I was reading some stuff about D-modules in here. There's some calculations I still don't understand that I'm trying to understand. So let's just jump over to Char's presentation here. Right. So we have So we have here also, instead of exact sequences, right? We have what are called distinguished triangles. And so, for example, like in our long exact sequence of cohomology, right? We've got it's now like these complexes, right? So this is an object in the derived category. These things are objects in the derived category. And now we have, like, there's this +1 map going back to this sequence, right? So that's what makes this a distinguished triangle. Tangent sheaf cohomology at degree 0 spits out the vector space of tangent spaces. I don't think that's correct. Where were we here? So right, and so now, okay, we have a couple axioms. Well, let me just jump ahead to I don't think I've ever actually applied the octahedral axiom. I know it's somewhere buried in, like, the proofs of theorems that one uses for triangulated categories. But I don't think I've ever actually written it down for a proof myself. But here's the octahedral axiom, just because it sounds badass and it's a pretty picture. You were just checking? Well, I mean, if you don't want me to read your comment, then don't. I mean, that's the point of comments, is I read them. But if you have a question, if you're just checking, then you should ask it as a question. You should say, hey, is this correct? The octahedral axiom is just the third isomorphism theorem? Oh, really? I'm going to have to meditate on that. Let's see. Maybe I should meditate on that in private. A over C, B over C. Right. XY into A, YZ into C, XZ into B. Uh-huh. Right, so I guess I wonder, interesting. So maybe I should work this out. For example, like when you say that, Arad, does that mean actually I can recover it? Like if I just look at the, let's say, complexes in degree 0, probably, you know what I mean? The natural heart, if I look at the natural heart, then do I literally does octahedral then literally imply third isomorphism? Yeah, I mean, Arcturus, the thing that you've stated, the question you're asking doesn't even make sense. It doesn't even make sense to ask. Wow, that's amazing. Okay, I'm gonna work through it. Yeah. Actually, yeah, no, I'm gonna spend some time and think about it today. I need to do some work as well, but right in exact triangle. Right exact triangles is that. Right. So we're X, I mean, yeah, X we're treating as the complex concentrated in 1 degree, Y is the complex concentrated 1 degree, and this is the, I see. Put it in my next papers? Put what in my next papers? This? I don't think this is a paper level result. Hey, it'd be awesome if if we collectively collaborated on something someday. You should help me solve the Moore graph problem is what you guys should do. But yeah. Okay. I think that's it for today. Let's see. I have some things due for next time to talk about L packets and Arthur packets and the most profound result in category theory. Yeah, Arcturus, you got me on a roller coaster ride because I'm happy that you're actually, drilling down and doing basic math, but then here you are just saying words again, just word salad, and it's doing math is not just saying words. Like, yeah, Paul Murray said the words cotangent complexes, and like the questions you ask, just because you put the words together doesn't mean that your questions make sense. So I know you're excited, and that's awesome. I'm happy for you. I'm happy that you are taking some feedback seriously and working on basic things like logic. But, focus on those basic things. Don't, it's not very helpful to just throw around these words that you don't have a true understanding of yet. Like I said, try and stay patient and humble. You'll get there. But people can tell when you're just throwing words around that you're not ready to yet. and people don't appreciate it. You're not going to make more mathematical friends that way. So, Arad, amazing, coming through with the deep questions. Okay. That being said, I'll see y'all, tomorrow, probably. Just basic college math on else? Well, I mean, just you can read more advanced things, but just don't pretend that you... Like, if you don't actually know the definitions of these things yet, there's so much more you have to do before you're ready for algebraic geometry. Getting in the Lang is hard. It takes years of actual comprehension and being fearless. Being fearless is important, yeah. Being fearless is important, but you also got to be patient and work hard and recognize that it takes many, many years to digest all of these concepts. So, time to go digest some concepts, yo.